Okay, this is a lesson that I really wish we were all together, as I probably am going to wish that we were for many of the lessons that are to come, as we are approaching or diving into the topic I call sequences and series. It's the last big topic in this class. There are a couple small things afterwards, but and this is really weird. All I can tell you is as we go, we take it one day at a time. It's really, really important to understand each thing as we go, or you'll end up really finding yourself lost. So we're going to do a gentle introduction into sequences today. So this is something you may have learned about in pre-cal, but I don't know if they skipped it, especially for you. Oh no, that wouldn't have been pandemic here, but I don't know. So a sequence is basically just a list of numbers that follows a certain pattern. But of course, it's not that easy. So when you were maybe taking the SATs or whatever, you saw sequences. One of the ones that we study a lot is this sequence: 1/2, 1/3, 1/4, 1/5. This is a sequence, and so on. So it follows a pattern. The denominators increase by 1, and we're going to end up with like general terms for sequences. Now we're only going to talk about sequences for like a day or two, but in general, we want to understand that I could write this sequence as 1 over n. And n would, in this case, start at 2 and then increase by 1. So when we talk about n as like a constant, that n is going to represent whole numbers, and we'll be using our counting numbers. We'll be told where to start, and then we'll be plugging in values for n, starting at that starting value and then increasing by 1 as I go. So I could say this series can be represented by this function. There's lots of different series. I could say a sequence. I don't mean to use the word series. These are all sequences. This is another sequence: 5, 25, 125. Oh gosh, I don't even know what the next one would be. This is 5 to the first, 5 to the second, 5 to the third, and so on. This sequence could be represented by a function 5 to the n, starting with n being 1. 5 to the first, 5 to the second, 5 to the third, and so on. What we're going to be asking ourselves in this first part is, does the sequence we have converge, or does the sequence we have diverge? This is going to be different than improper integrals. With improper integrals, we were wondering if the area under the curve diverged or converged. So if my function was decreasing, the area was getting less and less, so it was possible that the value or the accumulation of this area was something that we could calculate numerically. It was also possible that the area under this curve was too big and would ended up being infinite. So again, a reminder, when that area was infinite, we would say that the integral diverged. And when the area was able to be found numerically, I would say that the improper integral converged. Similar vocabulary here, except we're not talking about area. We are now talking about just a general sequence. Do our numbers get closer and closer to a certain number? And if they do, then our sequence will converge. If that number that they're getting closer and closer to is infinity, then our sequence will diverge. So if we look at this sequence, 1/2, 1/3, 1/4, 1/5, what number am I getting closer and closer to? You can even think about this as a graph. So when n, we're starting here with n is 2, we have 1/2, n is 3, we have 1/3, n is 4, we have 1/4, n is 5, we have 1/5. What are my values getting closer and closer to? I'm getting closer and closer to 0. which I can also think about is the same thing as happening as n becomes infinity. So really what I'm asking is, what is the limit as n approaches infinity of 1 over n? Well, 1 over infinity is what I'm really looking at, and that is going to be 0. This one, on the other hand, when n is 1, I'm at 5. When n is 2, I'm at 25. When n is 3, I'm at 125. My values are getting bigger and bigger and bigger, meaning that this sequence will diverge. Or if I look at the limit as n approaches infinity of 5 to the n, I'm going to get infinity, so therefore my sequence diverges. So we're going to be asked this: does our sequence converge or does our sequence diverge? Our choices are not 0 and infinity. Our choices are infinity or something numeric. We don't have to find out what the sequence converges to. We can estimate. Actually, you know what? Sometimes we do need to figure it out. We'll get to that in a second. But we basically want to know is just, does the sequence converge or does it diverge? Now, one other thing. So let's write this down formally. If the limit as n approaches infinity of our sequence, let's call it S sub n. If our limit equals a number, then the sequence converges. To that number. If not, the sequence will diverge. So if the limit of the sequence is a number, then the sequence will converge to that number. If that doesn't happen, the sequence diverges. Well, why didn't I say if the limit as n approaches infinity of the sequence equals infinity, then the sequence diverges? I didn't say that. And that's because there's more than just one option. So how can this happen? How can a sequence diverge? So a sequence diverges if one of three things happens. Well, and actually really one of two things happens. One, the limit of the sequence is infinity, like we just said. Or if the sequence oscillates. Okay, so what do I mean by oscillates? I mean by that goes positive, negative, positive, negative, positive, negative, and does not converge upon a number. So let me show you an example of that. An example would be -1 to the n. When n equals 1, this would be -1. When n equals 2, I would have +1. If n equals 3, I'd have -1. If n equals 4, I'd have +1. So that's what I mean by oscillates. Negative, positive, but I'm not getting closer and closer to a specific number. So just because something, I should say the sequence oscillates and, does not converge to a number. I say that because there's an exception. We can have an oscillating sequence that converges. We can have a sequence that goes positive, negative, but does converge. It would look like this. So let's say, does the sequence, and let's give it this look, -1 to the n over n. Does this converge or diverge? So it has this appearance of the -1 to the n. When I see this, I know my signs are going to swap. I'm going to go a positive and negative, a positive and negative, or vice versa. I'm going to go every other, because that power of n as I increase is going to give me a negative number and then a positive number, then a negative, then a positive. So let's see what happens. We're gonna always assume we start with n equals 1 unless we're told otherwise. So don't get too stressed out about the whole where are we starting. You'll know soon enough when we're starting. So for right now, just go with it. So let's just get the first few terms of our sequence. Well, if n equals 1, substituting 1 for n, I'm going to have -1 over 1. When n equals 2, I'm going to have +1 over 2. If n equals 3, I'm going to have -1 over 3. If n equals 4, I'm going to have +1 over 4. N equals 5, -1 over 5, and so on. So you can see the pattern. Well, think about this like graphically. What's happening? I have, here's -1, here's +1. When n is 1, I'm here, and then I'm at 1/2, and then I'm at -1/3, +1/4, -1/5. What's happening? What am I getting closer and closer to? I'm getting closer and closer as I go to infinity. I'm getting closer and closer to 0. So as I continue along and I have -1/5, +1/6, -1/7, +1/8, I'm getting closer and closer to a y value of 0 there. So this is a good way to think about an oscillating sequence that does converge. Whereas the other one was -1 and 1 all the time. I was -1, +1, -1, +1, -1, +1. I got no closer to something. This, I got closer and closer to that y value of 0. This is kind of the perfect way to show you that, that what I'm also kind of looking at is, I'm looking at horizontal asymptotes, basically. I'm looking at, if I can think about this as kind of a function, what am I getting closer and closer to? I should be getting closer and closer to a certain y value, which is basically a horizontal asymptote. So this sequence has a horizontal asymptote of 0, kind of technically. It's not quite that, but it has that general idea. I'm getting closer and closer to 0 as I go out to infinity. Okay, so basic understanding of a sequence is it's a pattern. It's numbers that follow a pattern. The pattern is often described by this thing that I can think about kind of as a function. And if I think about the numbers of this sequence, I want to know, do we get closer and closer to a certain number, in which case the sequence will converge? Or do I blow up to infinity, or oscillate and not get closer and closer to a number, in which case I diverge? Okay. So I know you're like, oh, can I have an example? So before we get to an example, let's just look at one other thing. How do we know if certain things converge or diverge? Well, one way that we know is just to look at the things that we just talked about. Give ourselves the first few terms of a sequence and see what happens. But what if we don't know? So what if we can't tell? What if we can't tell easily whether the sequence converges or not? Well, one thing we want to look at is that limit as n goes to infinity. What's happening to the function? Any function that's increasing is not going to give us a sequence that converges. Any function that's increasing in values is going to give us a sequence that diverges. So one thing we can do is just ask ourselves, does the sequence we have get smaller, or does the sequence we have get bigger as I move along? So how can I tell if a sequence is getting, or I should say, is increasing or decreasing? We're going to compare the top and the bottom. So most times we're going to have a fraction. So sometimes we're just going to think about it. So for example, if I had this series, I'm sorry, I keep saying series, I mean sequence. If I had the sequence like before, 5 to the n, obviously that's increasing. It's getting big really fast. So I don't have to do any like real thinking about that. So therefore this is diverging. Sequence diverges. But what if I have something like this? What if I have n squared over 2 to the n? Does this converge or does it diverge? So you can get the first few terms, but things are going to get potentially a little funky, and you don't want to always plug stuff in. You can. Let's say you decide to plug in a few things. Let's say we start at 1. I'm going to have 1 on the top, 2 on the bottom. Plug in 2, I'm going to have 4 over 4. Plug in 3, I'm going to have 9 over 8. Plug in 4, I'm going to have 16 over 16 again, right? Plug in 5, I'm going to have 25 over 32. Plug in 6, I'm going to have 36 over 64. I'm a little confused. I'm not really sure what's happening with this sequence. I've got 1/2. This is 1. Let me keep red, sorry. 9/8. This is 1 again. 25 over 32, 36 over 64. I don't love what I'm seeing. I feel like the pattern is kind of confusing. I'm not even really sure what it is. So instead of thinking about what pattern the numbers make and what's happening to them, I instead am going to think about what's growing faster, the top or the bottom. If the top is growing faster, this sequence will diverge as I go to infinity. If the bottom is growing faster, the sequence will converge and become 0 as I go to infinity. So I want to figure out which is growing faster, the top or the bottom. I'm going to give you a chart in just a second. So in this case, which grows faster, a parabola or an exponential function? You could graph them if you want. This is not what you actually have to do, but I'm just saying, just to think about it for a second. A parabola goes like this. I have 0, 0. I've got 1, 1, 2, 4, 3, 9. My exponential function is going to stay, or is going to be here. 1, 2, 3, whatever. Okay, I'm graphing it terribly. Don't really care. I know that my exponential function is going to grow way faster. No, terrible graph. I'm doing a terrible job because I have nothing drawn to scale. Go ahead and take your graphing calculator, pause it, and show yourself because I don't have mine next to me. This grows way faster. Once I get beyond a certain number of x values, this grows way faster. So since my bottom is growing way faster than my top, the limit as n approaches infinity for this will be 0. And therefore the sequence will converge. So I need to be constantly asking myself with these sequences, which grows faster, the bottom or the top? If the bottom grows faster, the limit will be 0, the sequence will converge. If the top grows faster, the limit will be infinity and the sequence will diverge. So do we need to write that down? I wish you could answer me, but I'll write it down. If top is growing faster, the limit as n approaches infinity will be infinite and the sequence will diverge. If the bottom is growing faster, the limit as n approaches infinity will be 0, and therefore the sequence will converge. Whew. And if bottom and top are growing at the same rate, the sequence will converge to, how should I say this? To the horizontal asymptote. I'll show you an example. This should all ring a bell. Okay, this is why math is so cool, because it builds on each other so much. What the heck is this? These are the same rules as we have for horizontal asymptotes. When in pre-cal we were talking about horizontal asymptotes, we would always say, we're going to compare the top to the bottom. If the top's growing faster, that means we have no horizontal asymptote. The limit's infinity. If the bottom was growing faster, we would have said we had a horizontal asymptote at 0. And if the bottom and top are growing at the same rate, we would say we have a horizontal asymptote at the ratio of the coefficients. Remember that whole thing? Now we're going to be basically giving that as our answer, but now we're like relating it to this sequence convergence. So how do I know what's growing faster, what's growing slower? Like I just had a parabola compared to an exponential function. I know that exponential functions grow faster than parabolas. So let's just do like a little pattern here. So let's say slowest growing, growing, to fastest growing. So our slowest growing thing would be 0 or any constant. That's the absolute slowest growing thing. The next would be something that's linear. The next would be quadratic, or then we can obviously increase by cubic, quartic, whatever. So then we would say like x to the power. That would come next in terms of fastest growing things. Obviously this would be like x squared first, then x to the third, x to the fourth, and so on. Growing after this would be exponential functions. So that would be like e to the x, 5 to the x, anything to the x. I don't think I'm missing anything, although now I'm gonna be like, oh gosh, oh, you know what I forgot? Haha, as I say that. There's something that we have to squeeze in right here. Between something that's constant and something that's linear is natural logs. Logs. So natural log of x, whatever. So let's see, we got constant linear, or constant logs, linear, power functions, exponential functions. I will give $100 to the person who can text me before watching the rest of the video what the next biggest function is, and the biggest function of all, oh, I didn't get a text. The biggest function of all is factorials. What? Factorials are gonna become a thing? Yup. So that would be n to the n exclamation point, n factorial. Do you remember what those are? We're gonna be studying them a lot actually. Oh, it's gonna be exciting. That's, if you remember, like 5 factorial is 5 times 4 times 3 times 2 times 1. Yeah, well if we have x factorial, it's gonna be the fastest growing thing that we have. Okay, so now when you compare stuff, you can use this little list. So if I said, oh, I don't feel like erasing. Let's get a new board. If I said take this sequence, 2 to the n over n factorial, you can get yourself terms of that sequence if you want. So you can plug in 1 if you want, you're going to get 2. You can plug in 2 and then you're going to get 4 over 2. You can plug in 3 and now you're going to get 8 over 6. Plug in 4, you're going to get 16 over 24. Blah, blah, blah. I don't even, I don't know. This is 2, this is still 2, this is bigger than 2 now, or this is between 1 and 2, now this is less than 1. Like, what? Can't even tell what's going on. So without having to go super, super far, we can just look at this and say, what's happening? Which is growing faster, the top or the bottom? Well, factorials are the fastest growing. So the limit of this guy as n goes to infinity is 0. So this sequence is converging. So I'm going to go through, just ask myself, is the bottom growing faster? Is the top growing faster? What is going on? Okay, I gotta stop talking now because it's just way too boring and it's long enough. 24 minutes? Hello. I'm going to throw some problems out there and I'll do the answers.